Okay, great. So our new assignment is O2F, interoperability and BIM objects. So what we're going to do is we're now going to, once we have our, oh, and you know what? I'm not sharing my screen. Now that we got a good set of, let's say the client really likes what we're doing, and we need to start to put together a really conceptual, a really early SD package. And does everyone see my screen? Okay, great.
That's good.
So what the first thing we're going to do is we're going to start creating some families in Revit, and particularly an adaptive model family. And I'll go over all this shortly. So we're going to create an adaptive model family. We're also going to create a title block family. And then there's a plugin that we'll have to download called Hummingbird. And once we download Hummingbird, we're going to open up Rhino and Grasshopper. And we're going to reference not so much of O2A, but mostly a lot of O2B again. And our latest, and O2B also contains our latest massing model. So we're going to reference a lot of those parameters, and we once again have to break apart our massing model, and we're going to have to break it up into panels. That's also important because that's how we're going to later on we'll construct this. Through fabrication later on. And so using the plugin Hummingbird, we're going to transfer all that data into an Excel spreadsheet. And that Revit will read that Excel spreadsheet and generate native geometry. So that's really important that it's a native, now it's no longer just a dumb geometry that's imported. Revit recognizes this as it's a native Revit geometry. And so we're going to create, since we're going to import all this from Grasshopper into Revit, this will all be, and we're going to generate 4 exterior elevations and 1 building section. And we're going to put them onto our newly made title block, and we're going to PDF those 5 pages, and we're going to export our high-res Grasshopper script and submit that as 1 PDF. So since also next week we have spring break, so this is more, this won't be due next week, it would be due in 2 weeks. So you guys, I still highly recommend jumping on this because again, Revit might give you a hiccup. So we're gonna jump right in. So Revit. This is when you first log into Revit, open up Revit, you'll have this interface, and we're just going to jump right into a new file, and we'll just do an architectural template for this one. All right, so this is Revit. We have our tabs up here, which will be our architectural, our doors, windows. We see our structural, steel, a lot of these tabs we won't touch, and we don't need them right now. But we do have some insert tabs, collaboration, manage. We also have an add-in plugin, a tab. And when you click on that, once you download Hummingbird from the Food for Rhino, and more of that information's in the assignment, that will be located here. And we have our modify, we can start to modify the geometry. So some really basic stuff is default, we start at level 1. And level 1, we have our, and this is what our properties are, which is that controls our view properties. So right now this view scale is at 1/8 inch. We can always change it if we need to. And we can change it. So if we need it to be a 30-second, it's real, and we can change that. Now it's really important later on because views are if you have a title block and you want to drop your view into it, your view is set to that scale. So if you have a very large title block and you have a small drawing and it's set to a small scale, it's going to show up really small on your sheet of paper. And you're like, why is that so small? I need it bigger. Well, you need to update your view scale on your based off that view. And views are specific to sheets. So you can't have multiple views on, or you can't have multiple sheets that have one view on it, if I said that right. So if I have one view, I can't drop it multiple times on a sheet. I can only use one view for one sheet. Again, these are some of the rules why Revit is a little is strict, but when you're cranking out drawings, this helps make, this is why Revit is so productive, because it has these very strict rules. So, for example, if we want to draw a wall, when we click on the wall, it comes up with just a basic generic wall, 8 inch. There's nothing made up of this wall. It's just a blank generic 8 inch wall. But we can start to define what this family is, and we can actually start to say, okay, we can say this wall now is an exterior brick and CMU on metal studs. And we can actually start to edit these properties of this family, and we can actually start to construct what this wall assembly is. Now and we even start to see our thermal mass, our R values. This is why Revit's such a workhorse and why it's so great to get consultants in, because then we can get structural in, and they can start to perform structural analysis on our models. It's also, we can do some thermal studies, make sure that, or energy studies. All this is why it's so, this program is so great, is that all this information is based, even our air barrier, our membranes, our structural. We can start to define all that, and we can start to make our own families, which is really great. So let's just use this wall for example. If we want to start to draw it, we have when we click on wall, our family pops up here, and we have our lines. We can switch to a box, and we can start to draw it like that. And there's our wall. We can also start to adjust some of the visibility graphics. So we can start, right now it's coarse, so it's not going to show a whole lot of detail, but we can say fine. We can zoom in, and we can start to see the wall makeup. And right now it's flipped up the other way. So we can always rotate it, and now our brick is facing out. Also, when we make, and notice when we do that, that flips some of our stuff. So we can actually, there's a shortcut. If you click space, it automatically flips it when you highlight it. But you can also select certain portions of this. You can tab through, and you can highlight just this wall, or if you hit tab, it highlights the whole thing. There's just small little things like that you deal with. Again, we have such little time to work with Revit, unfortunately. It's going to be some of the stuff we won't dive into too much in this class. But it's really important to at least understand that some of these concepts exist, and that how the basic functions of them. We can also start to explore 3D views. Now, 3D views are a little unique because they won't have a scale to them. Well, I guess they do have a scale to them. I lied. But we can start to see our massing in 3D. Let's go back to our level 1. And we can start to incorporate doors into this. And when we cut a door, it automatically breaks the wall, and it's and we can adjust the door swings, how it moves. And if we go back to 3D model, we can always rotate around. There it is. We notice that it starts to break in. Now, what if we want to change some of these walls around? Well, we could always start to edit the profiles of these walls. And so we can always bring this down. Actually, I don't think I can do it on this one. Constraint. We're just going to bring this one down with it. Yeah, it's going to tell me that's unconnected. It's okay, but we can start to change some of these walls up and start adding a little profile. And you can actually start cutting holes in them. And we start modeling like that. Now, you can, and that's part of how people go back and recreate some of our SketchUp models and our Revit models, are going through and just, taking a CAD or 2D floor plan from Rhino and just start tracing over it with these families and drawing it. And we have our walls, we have floors, and we click on floors. Again, there's makeups, there's 3-inch lightweight concrete on 2-inch metal deck. So we can start to draw our floor. We'll just draw a quick floor. And sometimes you may notice that it's like, wow, this is really difficult to read. These lines are pretty heavy. There's under view, you can say thin lines. And there you go. You have a nice, now change the profile of that. Now, be careful when you do thin lines that you no longer see some of the line weights that are being portrayed. But it's just a little easier now to make things. And we can create our floor. And there it is. Now we start to see our concrete hatch. We actually start to see it. And we can always edit our floor boundary if we need to. We can start to punch holes into it. But a lot of that, again, it just goes back to how we do some of this. So we actually start to add a roof. We can create roof on one side. Yes. So we're going to jump to level 2 because we have 2 levels on that. And we can start to create a roof. And we can, and just like with CAD, there's some offset. So we can start to see defined slopes or offset. So if we want like a little overhang of the roof, we do a flat roof, we can do a hip roof. There's a lot of great. Let's just offset this 2 feet. Oh, maybe you have to it offsets when you draw it, but you can do an offset as well when you do that. But once you let's do it, and we can define our slope. Actually, define slopes. Yeah, we'll just click. And we can attach the roof, and this roof is not interesting at all, but we can start to define some of the slopes to us if we need to, and we can actually move it up and down. But that's some of the nice things is, again, we did this in CAD. There we go, we have our properties right here. We can start to, if we did this in CAD, this would be something that we would have to figure out. Well, it's great that Revit figures this out for us, and it builds a, we can start to add a family to it, the makeup of what that roof is, if it's going to be wood or steel, or we can start to cut sections of it. So speaking of sections, we can actually go into our level 1, and we can go into our view tab, and there's our section. And so when it comes up, it's just a simple cursor, and we can drop and drag, and just very similar to how sections are read, we can read it this way, or we can flip it, or sorry, we can change our viewport if we need to. Oh, there it is. And it can go the other way. So once we drew that, if we want to go to that view, all our views are back at, let me just move this up a little bit, are back right here. This is our project browser. So any views, sheets, families, legends, sections that we made will all show up here. And second we drew that section, look, we have a little new view right here, section. We can click down that, and we jump to it, and there's our section of our building. And we can always adjust how fine it is. Of course, this is just a simple generic roof, so it's not going to show up too much of the section. But at least we can start to see the CMU and brick on our walls and the metal stud. What if I have a 3-story building? We could always take this, our level, we can copy it, which is or you can type CO, and we can copy this up. And of course, it's going to go into feet intervals. So if we want to go like a 10-foot, now that automatically created our level 3. And if we want our 3rd floor plan, we go plan views, floor plan, level 3. Click OK, and it just created it. And so our level 3 is pretty much see, we're actually cutting off a little bit of our peak. So if we jump down to our elevation, see, it's taking that section. And we can always control these on how, like where it's actually cutting the floor. So like traditionally, like a floor plan is a horizontal section cut that's 3 feet off the finished floor. In Revit, we can always change that through our view properties. But again, this assignment, we won't be dealing too much with that. Like I said, this is a massive program. So we're going to just try to keep things very basic. Elevations, a lot of elevations are already set for you. So if we click on east, it'll automatically jump to our east elevation, and it's already created for us. Same with our north. And when we go to all our elevations, our section cuts appear in them as well. Now, if you don't want that, sorry, I'm getting a little bit of a lag here. If we don't want that, we could always highlight it, and we can always hide it, and we can say element. So it's similar to Rhino. It's hiding elements. We never really want to delete elements, but if we hide it, we can always get it back by our views, which should be crop view, show, temporarily hide or isolate. Oh, did I just mess that up?
It's the light bulb.
That's it. Thank you. Yes, hide and
No,
no, it's that one. Yeah, okay. Yeah, and that puts us right into the reveal hidden elements. And we can always reveal that on hide. I'll go back into it. So again, it's a I like to think of it as Revit as a like glorified Excel spreadsheet. Everything is organized into families and everything is quantitative really quickly, which again makes production really fast and efficient. Can you design it? Yes, you can. And I know designers that use it and use it solely as design and production. But again, there are some little some hiccups with it. So the first thing we're going to do for the assignment is we're going to start a new family. So we had all our families, our wall families. We're going to do a family and we're going to create an adaptive family. So if we're going to slide down, it should be default right into our families list. It's if you don't, it should be right into family templates. It's right, should be right in your C drive. And it jumps right in. We're going to do a generic model adaptive. We're going to open that up. And right now it's just going to be a blank canvas. And what this is that it's adaptive component. So it's going to be defined by, it's going to be an object that's going to be defined by points, which is exactly what we like in Rhino and Grasshopper, are points, lines, and surfaces. So we're going to create a simple, just 4-corner box. So we're just going to, and when we start off, we have our create tab. We're just going to go right into our point element. We're just going to draw 4 points. We're going to click escape, and we have to make these adaptive. Right now, these points have no relationship with each other. So once we highlight the point, we have a tab called Make Adaptive. And we're going to click that. We notice a little box, some Cartesian grids come up, some reference planes. So then we're going to, and we notice a 1 appears on top. We're going to click the next one. We're going to do it again. Click Make Adaptive. I'm going to click the other one, Make Adaptive, and we notice 1, 2, 3, they all go in order. We're going to say Make Adaptive. So we have 4 points. We're also going to create a surface that's defined by these 4 points. So we're going to grab a polyline, which actually, or just a line. And it's really important when you create this line, we want to make sure 3D snapping is turned on. So make sure that's clicked, and make sure Make Surface from Closed Loop, that's activated. And you could have a chain. Chain means you just don't have to click line over and over again. But we're going to hover, and we notice just like how AutoCAD and all these great programs, it's going to snap to that line. We're going to click on that point. We're going to click on this point. We're going to click on that one. Click on that one, and we're going to close it off there. And bam, a surface just automatically appeared. We're going to click on Modify. Now we can always click on that surface. And remember, if it's not clicking, we can always click Tab, cycle through. Where's that? But when we do that, we can do Create Form, and this essentially extrudes it. Create the form, we can define, we can define its extrusion if we want it to be extruded. And what we're essentially doing is we're creating the curtain wall of this object, of this tower. So we're just going to make this pretty small. We're going to do it just won't. We'll just do 1 inch. So now we're going to load this into our project. First, we're going to save. So we go into File, Save As. We're going to do Save Family. And we'll save it to one of your local files. We'll just call it. Now it's really important to keep in mind of this name because we're going to call it curtain wall test. I'm just going to call it 2. We're going to save it. We're also going to load it into our project. And when it does this, it kicks us into our Revit. And we're going to, and our family is already highlighted. So we're just going to click our points because it's looking for 4 points to define this thing. As we notice, when we click these, it's changing the shape around. And right now we really don't need it. We just need it in our, we're going to exit out of this. We just need it in our Revit. And that's the key thing is that Revit uses the families. Every time you make a family, you have to load it right into Revit because Revit doesn't know that has this family. And there's our little block. And we can always go back and edit this if we need to. And when we double click it, it kicks us right into our family. And of course, some of these points are going to be different because these are adaptive. All these are, they're parametric, but they're instances of each other. Or not, they're not instances, they reference a logic to it, but each one is unique. We're just going to delete this for right now. So we have our point or that. We're just going to delete that as well. The next is our title block. We're going to go File, New, Title block. And we're just going to open up a new size. It comes up with, here's our little 8.5 by 11 sheet. And we're going to do an ArchD paper size, which is 24 by 36. But we want it to be vertical. So we're going to, and the nice thing about Revit is you can just click these sides and we can start to define our object. So in fact, we'll click this one and we can just click on our dimension string and we can type in 24 and moves it so it's 24 inches. We can do the same thing here. Oops, same thing there. Move that, we'll say 36. We're just going to delete these. And then we're going to just go into create. We're just going to make a little text. We're just going to start a note, and I'm just looking for just some really simple. We'll just say name, class, date, semester. Something simple like that. And same was like what we did with the other one. We're just going to File, Save As, Save Family. We'll save this as our title block. Great. So we're going to close out of this. We're just going to, and that's pretty much the extent of family making in Revit. So let's jump back into Grasshopper and Rhino. So we're going to open up our file with our city in it, and we're going to, I don't have geometry. And we're going to open up assignment O2F. And this part's going to be pretty similar to everything else. We're going to open up mass really quick. Here we go. All right, we have our mass. So I'm going to explain how this works with putting at least our curtain wall in, and then the rest is the rest of the assignment, which is adding the floors to this. We're adding the floors, adding the reference levels, and actually creating some walls in Grasshopper and transferring it into Revit. And the goal is just to have our sheets look like this, with our section cut, with our twisting tower, and all our levels right into it. So we're going to break this down where it's just like before. I'm going to grab that massing model. And just like what we've used in previous ones, we need our faces, edges. So we're just going to deconstruct this BREP. And just like, again, before, we just need the vertices. Actually, we're going to do the face, not the vertices, because we're going to divide this up. So we're going to grab our face. Once you know, it's going to bring this into our list items. And let's get our panel tool. See, there it is, trim surface. And we just want to make sure we don't need a top or bottom right now, because we'll assume we're going to make we'll assume our floors are going to make up our top and bottom. In this case, we can specify a roof, but to make things simple, we'll make it into a floor. So we're just going to plug in what's our very first one. Is that our what is that previewed as? Okay, that's actually our top. So we're going to take that out. I'm assuming that's going to be bottom. Here's our side. Yep. And we're also going to unpreview that. So we know now, here's our side 1. Should be side 2. I'm just going to unpreview all these. Side 3 and side 4. Great, so we have our pieces here. And just like with the simulations, we're gonna plug all these into our side 2, side 3, side 4. So when we have our max level, that's the number we're going to divide. I believe for this case, we're just going to use 56. That seems to be a common one. We're just going to plug that right into that. And we'll do that for all these. And now we have to divide up this surface into 4 points. Now, and we actually want to panelize this surface into, so that's the important thing, because we actually want to model, we want to 3D model every single unique curtain wall on this face. That's why we're doing this. So and that's why we have an adaptive component that's made up of 4 points, because so we're really modeling this pretty detailed, and we're going to have Revit recreate that for us. So that's why we're deconstructing this and breaking this down into pieces. So what this divide domain does is it divides that surface into segments. It takes the domain of that surface, and it's like, okay, I'm going to break it up into all these pieces. Now, isotrim actually cuts the surface. So divide domains, like, okay, I'll divide, this surface is made up of, is made up of 0 to 1. I'm going to divide it 10 times in both the, U and V direction. Isotrim is actually cutting that surface into that. So we're going to take our side one surface, and we're going to put it into I. Because why I? Because we're looking for that domain. We're going to put it right into that. And then we're just going to take our max levels, and we're just going to put it into U, because we need a factor to divide by. And we're going to then take this and put it into A, and we're going to plug that into V, because now that so it divides us up 56 times along this and 4 times down here. And then we're going to, and so to cut this, we need a domain and we need a surface. And now we're going to plug our domain right into the domain and our surface into that. And once when we unpreview this, it's all sliced up into a nice little grid. It looks like I'm getting some. Looks like it's overlapping something. There it goes. It's an overlap. So it cuts it. And also it probably why we're getting that weird overlap. Notice that it's not very pretty. It's like, oh, it's weird. Why we get? It's probably because now it's starting to get. It's not as smooth now. I actually had to break it into some pieces. So that's why it's getting some weird shape. So we're just going to plug this into a parameter, because this is just a nice technique to keep things organized. And you guys should be familiar how a lot of the scripts that I write go into it. And we're going to plug that right into this. So we have this script, we have this face broken up now. It's broken up into pieces, but we need it to be broken up we need the points, right? So we got our full face from one solid piece, and now we've broken up into 784 unique surfaces. But that's not enough, right? Our adaptive component that we made in Revit is looking for 4 points. So we have to break this surface down even more to extract those 4 points. So that's why we have another deconstruct BREF. And that's why we take our divided surfaces and we're going to plug that right into it. But this time, instead of faces, because we already have the faces, we're looking for the vertices, the points that make up these faces. We need all 3,336 faces. So we're going to plug that right into our list items. And we need to list those 4 points. and see, we can actually see, okay, we have all these points now, but we need certain points. And we need to, so we're going to merge these, right? Because the way we want to make sure, so we have, all the 0 points. So every little one of these points is set up as a 0. So like, for this surface right here, it's made up of 4 points. So when we did the list 0, it's calling out that 0 point, that 0 point, that 0 point, that it calls out all the 0 points that make that up. We can actually, so see, it isolates only a certain amount of them. And same with the other points too, right? So it takes up there's 4 points that make that surface up. So we need to call out 4 of these points. And the reason why we're doing this is we need a single list, one that doesn't have any branches, but or we need to reorganize this list so it has in a single branch 0, 0.1, 0.2, and 0.3. That makes up the surface, and that's one branch. So it's like that right now, but we're still want to deconstruct it and reconstruct it to make sure it goes in that correct order. Sometimes, like I said, when Revit reads things, it sometimes reads them a little differently than others. So that's why we're deconstructing it and reconstructing it in this exact order. It might be already in the correct order, but you may have, the mass might have been generated a little differently than yours than mine. So we're going to break it up, and then we're going to merge all these pieces back together again. You don't really need a fifth one. And once we have our merge phase, we're going to go into this one. This is something. This is a newer component, but for this class, but it's a partition list. And what it does is it takes every 4th item on the list, and it's 4th because we can say 4, or it can be every 3rd, or every 4th item is going to create a branch. So right now, our data tree is flat. It is one flat list. And we need a branch for every surface. So that's why we're going to take our list and we're going to plug it right down here. And let's grab our data tree now, and we should have our 700 branches. 1254. Oh, yes. So these are actually, those are our points, my bad. But they're all created into branches for that. We're going to delete that and we'll put our panel. Do that. Oh, because I forgot to plug in 4. There we go. So yeah, now it says, okay, 0, 1, 2, 3, 4, 0, 1, 2, 3. So those are all our these are the X, Y, Z coordinates for each one of those points. And that's really important because that is the information that Revit is going to read to put point 1 there, point 2, point 3, and point 4. So a little bit of, remember Grasshopper, when it's in Dynamo, any visual programming, 0 is a number. So, but in the adaptive components, it doesn't have 0, it starts with 1. So just remember that, you know, for Revit, it's always 1, 2, 3, 4, and Grasshopper, it's 0, 1, 2, 3. But now all these 4 points right here make up that one surface or that surface around here. But we have reorganized our list that it creates these surfaces for us. And we're just going to plug it into our points. We're going to hide it. And this is our Hummingbird component. So we're going to plug our points into our points component. So what is this? This component is an adaptive component for that generates adaptive components in Revit. Or let me rephrase that. It creates an Excel spreadsheet that Revit can read to create adaptive components. So there's also a whole bunch of different things that Hummingbird can do. We can do field regions, it can do grids, lines, levels, rooms, beams, curtain walls, and all sorts of things. One reason why we're doing an adaptive component instead of a curtain wall is, again, I talk about rules that Revit has to follow. The rules that dictate the curtain wall family is that they always have to be 90 degrees. Now, we can make a curtain wall not have 90 degrees in Revit, but we have to edit that geometry to do that, which is very time consuming if every one of those is a unique piece. Also, if you have a certain face, a longer face than the other, sometimes Revit will justify the curtain wall to a specific edge, and now instead of having your curtain wall going perpendicular, true perpendicular, like up and down, it becomes perpendicular to that edge, so everything's become slightly slanted. Those are just some of the issues that we have with Revit, and that's what we actually had to deal with on a project where we had a really complicated curtain wall that was curving in 2 directions, and in the time frame that we had, it would be very difficult to 3D model in Revit and use the actual curtain wall families. So in this case, this is what we did, was we used an adaptive component to generate all those unique panels. Later on, one of our architects was able to 3D get it as a Revit curtain wall. However, it took them 3 days to do it. And this just helped move the project along. Some people really want this to be Revit families. I totally get it, but this also, it can be adaptive components, and you can change your adaptive components to have it look like a curtain wall if you need to. So what this does is, again, just like exactly how adaptive components function, it uses points to control those surfaces. So we input our points into adaptive components. It's looking for a toggle. So it's saying, so the very first thing is set true to write a CSV file, which is a CSV file is very similar to an Excel file. It's just it functions very similar. It's just a different file type. In fact, CVS is anytime you have a comma, when you create that file, it automatically knows to jump to the next column. And I'll show you the file that when it creates it. But it's looking for a Boolean toggle. Now and in this case, a Boolean toggle I just made as a button. So every time you click this button, it says true, becomes a true statement. So normal, it's set as false. When we click it, it says true. So it's a great just a little component if I need, hey, let's write a Excel file. Click it, and it creates it. So we're just going to take this, we're going to plug it right into our Boolean. Now our file path. So our file path is the path that's actually that we're going to map that. And the best way to do it is, I take whatever file that I'm in, and we're just going to right click, copy address. Go back into Grasshopper, control paste, and paste that folder file right in there. We're just gonna put it right there. And we're gonna take that file path, we're just gonna drag it right into there. It's also gonna say, what's the name of the CSV file? Okay, we're creating this file, what are we gonna call it? So we're just gonna call it curtain wall. You know what, did we do it? And this is where we should probably write down what our components are. We can actually know we have a whole dictionary of all our families in our browser, our project browser. So we can just say generic models. We're gonna curtain wall test _2, all caps. Now it's really important to make sure you match that exactly. Probably just do an edit. Oops. Oh, did I jump? Whoops. Don't save it. Sorry, I thought we could. No. Just to make sure we can do a. Let's go back into that. And I like to name the file the exact same name as our family. We're going to drag and drop that right into the file. And then it's asking us for our family. Revit adaptive component family name. And now again, this is important to just know, this is where it's really important to know that you're typing in the correct notation, including if you accidentally clicked a space at the end, that will screw it up because it's adding an additional character. So we really have to make sure that name matches the name in Revit. We're going to do that and put right into family. All these others don't really need to be filled out. We can add values, we can have, for me, I actually, this was enough for it to work. Some of them you do have to fill everyone out, but in this one, we don't need to worry about it. It's not, some of this information, it won't need it. It's fine to leave blank. So we have that one. So we have this one wall made up. All right, let's go back into Revit. Oh, my bad. Let's actually create this CSV file. So let's click our button. And that's it. We just made a CSV file. Let's go in, and here it is there it is. And this is our file that will create some Revit geometry. And here it is, values 1. These are all our points and all the decimal places. And these are all the unique surfaces that it's going to create. So we're going to minimize that. We're going to go back into Revit. Zoom out a little bit. And we're going to go into our add-ins and we're going to do model builder, Hummingbird. We're going to click that. And this prompt comes up and we're going to create elements from file. And we want to make sure we click the right folder. So we're going to click reference the folder. So we're just going to reference this. It just needs a folder. And it's automatically going to detect CSV files. And when we do this, we can leave almost all this blank. We really just want to add all new elements. Do not delete any existing. And we would just want to make sure our adaptive component is set to curtain wall test 2 or whatever you call it. And that's about it. Everything else, these are pretty much the options you click on. Everything else in the rest of the assignment, you don't need to navigate. You really just have to set the file type, click on, because it won't read, it can only read one CSV file at a time. So you'll do the curtain wall test, you click process, it'll go through the motions. And then when it's done, you go to the wall, okay, process, and it'll make the walls. So it's, and I'm just going to move this over here so we can see a little bit. And we're just going to click process. That's weird. Hold on. Not able to connect. Am I in the file? Maybe it's because I'm in save. Oh, there. Oh, apparently it does not like people being in the file. So let's see if we can't zoom out. So right now it's building. And of course, it's way out. Cancel this really quick. Close this. Okay. Let's redo this. Great. Hold on. Process. So now it's going through and it's creating, it's reading all of the Excel spreadsheet and it's generating our geometry from Grasshopper into Revit. And depending on how complicated the shape is, it may take some time. But this was a really, this saved us a tremendous amount of time on other projects where it was this very, we called it origami because it looked like folding paper, but it was very much a, these fins that were all these unique fins. And the rest of the project was in Revit, but these fins were so unique and so complex, and the shop fabricator worked in Grasshopper. Those were in Grasshopper. However, the two had to talk because our building consultants and our structural engineer needed to know where these panels hit on the building and need to reference them. We also had to have some true elevations to show to the city. So this is exactly how we put them into our Revit file. Again, all the structural engineering for the actual panels were all through Grasshopper and Rhino, but the building itself was through Revit. So they had to make sure these talked. It would take, frankly, I don't know how you would the design that we did, I don't even know how you would design it in Revit or even model it in Revit because it was so complicated. But this saved us something that would have taken days to do. We did it in 20 minutes. And it was just a tremendous time saver for us to do. And again, it was just the benefits of having the two talk to each other. And it was much better than just doing a file import, because once we did that, we had to kind of, we always had to move things around and stuff, make sure it snaps to the right place in the file. With this, we knew where this was located. We had everything lined up already. So when we click this, it generated the panels exactly where they needed to go. So yeah, it's a huge time saver. And with this one, it will take some time. In fact, you know what? And thinking about this right now, I think, because this is taking a little bit longer than normal. So we're gonna change a variable really quick just to help speed this up, because this is just one side. We still have 3 more to go. So this file is gonna be really heavy and big. So we kind of want to speed things up a little bit. So we're gonna tweak a parameter for this that helps us speed it up. We're not gonna have as many panels. But you can see it does sometimes take a bit, but it's just a lot faster than 3D modeling it. And again, these are all the adaptive components. And the great thing is, if we change one, we change them all. So if we want to change the thickness of some, we can do that. Now, sometimes one face will be flipped. Of course, there's always it's something with generating things. Sometimes a face will flip the wrong way. You can either, since it might be so few of them, you can just physically move it, or you can isolate those 4 in the list and just reverse the order, which is a little more, it's more grasshopper. It's dealing with a lot of the data tree. It depends on how often you're going to be doing this. If you're going to be recreating this over and over again, it's really important to probably do that in Grasshopper, and so it'll always be fixed. If you're only doing this once or twice, yeah, I wouldn't worry about it. You fix it manually.
Did you say that you had to do each side separately?
No, we can do all the sides at the same time.
What was the thing you had to do separately? Because you said you could only do something at one time.
When you do different categories. So we have the sides. We do all 4 sides in one, but the floors have to be separate. The walls have to be separate. The levels. And the way it's set up, once you get the file set up and you click that button will create all 4 of those separate files. And this is why I want to change this up, because it's just a little slow and sluggish. But we can start to see it. We're really gonna cut back on this. But but there it is. It's actually starting to get a little, you can see some of the curve. We can actually, but this is what I want to change. It says divide by 4. We're going to set it to 2. And maybe that we might even want to set it to 1 if we really want to. That will help a lot. Now, the weird thing with Revit, and the big issue with a lot of the workflow, I see, like Grasshopper, we like to play and change things around, and it's the logic stays the same, but we can always tweak the parameters, and the object still stays the same, or still has the same element ID. Just like when we open up Grasshopper in our Rhino file, or we open up Grasshopper, and it immediately knows, oh, I recognize these elements, and it automatically snaps onto it. The same logic is in Revit, but the issue is with this is every time we run this script, this generates new element IDs. That becomes a big issue when you're starting to dimension things and reference these on sheets. The views may not stay, or views will stay the same, but anytime we start to annotate these things or grab some dimension strings, those dimension strings are specifically tied to the element ID. Another one of those funky things in Revit that I'm kind of curious of why they did that, but which makes this workflow not as fluid as we hoped. So there's always that caution of, okay, stop referencing, stop baking this into Revit, because then we have to start redoing work. So there's always a hesitant. There's always something that Revit does that makes it weird, that doesn't work out the best. Is it great for 1, 2, 3 time views? Yes. And when you don't have a whole lot of annotations to do, it's great. But as soon as you get pretty far ahead and you have to start recreating this, or you start to have some dimension strings and you have to start redoing some of your work, then it's not too good. But it's still a fantastic tool to get some complicated shapes in there and get them very close to your Grasshopper script. And we're just going to, and the nice thing is when we click the button again, it just saves right over this, and we can run it again. Hopefully this goes a little quicker. Yeah, and see our panels are a little bigger. Things should be a little, so this should help a lot. Still, and oh, you know what? Actually, I forgot to, no, we should be good. We should be good. Yeah, we should be good. So, but yeah, that's essentially what we're going to be doing for this assignment. But now we're going, once we have those walls, we're going to do the same thing for the levels, for the levels, for our actual floors, and for our core. So this is just a kind of a strange thing for our levels, is the length. So the logic of how we create these levels is we're going to take the center of our buildable area and the center of our scaled perimeter floors. We're going to merge them together. We need all those points, and we need those points because we're going to draw an STL line from it. So what does an STL line need? It needs a starting point, it needs a direction, and it needs a length. This is my one issue with this plugin, is you would think that the coordinates of that point will dictate the height of that, the height of the level when it's created in Revit. So what I say is, okay, you drew a line on level 2 and you use this component to transfer that level into Revit. It should be referencing level 2, but it doesn't. It floats out into space, and it doesn't reference anything. The thing that makes it reference which level to go on is its length of the line, which is, I think, is a little counterintuitive. So that's where the elevations of the line. So the actual, okay, this is elevation. The floor is 36 feet up in the air. That has to be the length of the line. which is a strange thing. And when you create this, it's going to look weird in Rhino because you're going to have all these weird lines. But that is how this component reads and generates those lines. So why do we need those lines? Well, that's just a standard for exterior elevations in the industry. We need to know the elevation of all these to understand some of the floor-to-floor heights. So part of the script, you won't notice them in plan, but you'll notice them in elevation. And all these will be generated through that script for you, so you don't have to. You can change them around, you can drag them around, you can mirror them so they can go on the other side of this, so they're not all justified. You can have this one on this side, and this one jumps out over here. Not good. I mean, the practice. I mean, you can, if it makes things look clearer, you can do that. But typically, you just want to keep it justified on one side. Yeah, I mean that's essentially how we get those elevation tags. The next one's the floors, which again, the floor, this example, this is just an exterior elevation, but we need the floors because we're going to be cutting a section. Just make the section in the center of the building. You know, don't give me a little sliver, actually just give me just half of the building. So we can see the elevator core cut all the way through the floors, or and we can also get the actual floors. So, or I'm sorry, walls. So when I want to do the walls, I'm just going to cancel this really quick. I feel like that one just took way longer. Close that. So when I do, to get the floor families, I don't have to actually create a family. We can just use the default. I'm not picky on which floors you use, but we could just use these 3-inch lightweight concrete on 2-inch metal deck. So essentially, I would write that down exactly how it is. Actually, yeah, lightweight concrete on metal deck. And when it talks about create floors, it talks about family type, lightweight concrete on metal deck. That's all you have to do. And it should recognize that family when you create that CSV file. And that's the same for your walls as well. You go into Revit, say architecture. Oops, where's that? Get out of this. It's not great. Click the X, red X. We can do walls, and we can type in any of these wall types, and it will create. And we just have to mimic this notation exactly in Grasshopper, and it will create that. And also, yep, I'll be referencing our floor elevations, perimeter of the building. With our floors, this is a curtain wall. The curtain wall is not going to butt right up against the glass. It's going to offset in. So in this scenario, I just put a default as an offset as -2, which means it's going to take all your floors that we just created, those floor lines, and it's going to offset them in 2 feet. The -2 might not work for you. It might stick the floors out 2 feet. If that's the case, just change this into a positive, and it should flip back. It's just something with your normals, how it creates the surfaces or creates the floor lines. Um, but yeah, that's essentially it. It's a so this is a tricky one just because you're dealing with two programs and also a program that some of you aren't familiar with. So take it slow. There are some great resources on Autodesk on just some basic Revit outputs if you really want, if you're having trouble, or just contact me. Um, but this is a really interesting way, or just really innovative way of how things are starting to work in the industry. Again, Hummingbird is it's still great. It's just they're not making any new versions of it anymore. 2020 is the last version that they've decided to make, and then it's just actually. And again, I say this is we're in some very new territory that just happened. That happened like a week after I wrote this, so it is always constantly innovating, changing, and things are. By the time we get this, there's probably going to be something that is new and makes things even easier. But Rhino Inside is the game changer one that is really interesting, and again, it's something I would hope to dig into. It's just so new. We just haven't had a chance to really dig into it and figure out the ins and outs of it yet. But it is a fantastic, conceptually, it's a fantastic idea. So with that, does anyone have any questions? We all okay, there's a lot to digest. There's a lot of new stuff to jump into. So again, I wish we had more time to explore Revit, especially dealing with conceptual masses, which is where you actually do start to design a little bit, and you start to create some forms, and it functions very similar to some like SketchUp. But like, and it all depends on the firm and like and your taste on how you design, and it's like I said, it's a process. It's all based on what you're most comfortable with. So, does anyone have any questions? Do people have questions on the last assignment, the O2E, that we want to cover?
Well, I do.
Yeah.
So for my ground plane, I am only able to get a blue field. So I was wondering if I could help with that.